Okay, next question is the same exercise. That's Haese and Harris F, I think. Haese and Harris exercise F. Someone circled 1A and has put a note in there. It says, how do we write it and show it as differentiable on an open interval? Can we say that it's differential because it's a polynomial in the case of A? And the answer is yes, okay? So in question A, it's just giving you this equation here. So f of x is 3x cubed plus 5x squared minus 43x plus 35. And here Rolle's theorem can be applied because f is continuous while polynomial functions are continuous on all real numbers. There's no issue of discontinuity for a function that's polynomial and it's not piecewise. So it's going to be continuous on -5 to 2 1/3, and it will also be differentiable on -5 to 2 1/3 open interval. So by Rolle's theorem, in other words, yes, you can apply Rolle's theorem. By Rolle's theorem, there exists some c in -5 to 2 1/3 such that f prime of c is 0. Okay, so f prime of c has to be 0 on there. Now, if we check to make sure, if you want to see Rolle's theorem, this is the note that we took. Oh, we need to also check one thing, which we didn't, and that, of course, is that the endpoints are 0, because what Rolle's theorem says is that if the function starts at 0, so for you guys, I don't know what side it's going to be. On one side it starts, and on one side it ends. It starts on one side, it ends on the other at 0. That means it had to come up and come back down, or go down and come back up. So at some point, it's going to have a flat tangent. Okay, so let's just back up to where we were, go back to where we're marking that question. Let's erase this. Let's start over there and just say we also have to show that f of -5 is 0. And I mean, I don't know, I would just do this on a calculator. I guess the easiest way is just to put the equation in there. Of course, we need to know what the equation was. Let's see here if we can do it in this kind of a way. Oops, let's see. Oh, we'll get there. Hold on one sec. And the calculator right in the corner here. There we go. And clear out. Oops, you go away. We'll clear that out. And we'll put the equation in. It's supposed to be 3x to the power of 3 plus 5 x squared minus 43x. That's looking pretty good. Plus 35. Okay. And we'll go to the graph, I guess. We'll graph it. Oops, that's not a nice graph. We don't get the actual graphing calculator view like the Texas Instrument with this thing. So let me just go to the table. And let's see here, we're looking at, you can see at -5, it's 0. Now, we want to know at 2 1/3, so if we go, we quit this here, where did quit go on this thing? There's quit, and we do, ooh, well, there's, why there's, no, oh, let me do that. I can see right up here, it says I need the pro. I don't have the pro version of this. I'm putting my face out of the way. Anyways, you're going to use your graphing calculator, and without me wasting my time with this thing, it's not really a GDC. If we do f of 2 1/3, this will all be 0 by our GDC. So now, Rolle's theorem can be applied. Okay, well, theorem can be applied because both of those guys, endpoints, give you y values of 0. Where could it not be applied? Well, you have to be careful in B, because in question B, as you can see, both the endpoints would give you 0, but this graph would, f prime of x would not exist at what point? Where would it have a kink? Well, it's the square root of x graph, I mean the absolute value graph lowered 5 units, okay? So it basically goes like something like this. Quick sketch, there's -5, there's 5. F prime does not exist at x is 0. So we can't apply Rolle's theorem. And in fact, that's actually an instructive one to take a look at. Why don't we do that in something a bit nicer like Desmos? Put a new blank graph on there. If I put y equals 5 minus the absolute value of x, oh, actually, it was upside down. Ah, we had minus, we had 5 plus, we had the absolute value of x minus 5 down there. Same thing, doesn't matter. We can still see there's a kink at x is 0. And you can see this satisfies Rolle's theorem because we have, oops, we got a 0 at -5, a 0 at 5. The graph is continuous, right? But unfortunately, the graph is not differentiable across the entire interval. It's not differentiable at x is 0. And in fact, there is no point where f prime of x is equal to 0. F prime of x is not equal to 0. It's simply not defined because it's a kink, okay? That's why it's very important to make sure when you're applying Rolle's theorem that the conditions apply. If it's a polynomial, it applies no problem. If it's not a polynomial, we have to be a little bit careful. Okay? Thank you.